In the figure below, not drawn to scale, ABCD is a trapezium. And given that AB is parallel to BC, area of triangle ABD is given as 54 cm square. Find the area of triangle BCD. Alright, so what we have been given in the question is that this whole thing is a trapezium, and they even tell us that AB line is parallel to the line DC. Alright, so first thing first, annotate the parallel symbol on your diagram first. Okay, using the two arrows. And area of triangle ABD, 54, so fair enough, it's already provided here, 54 cm square, and we are supposed to find triangle BCD. Okay, so if you look at this question, right now I have two triangles, very obvious, these two triangles are what we are working with. For triangle ABD, we have the area, 12 cm, most likely I would treat that as the base of the triangle. Okay, so what I'm going to do next is to create the height of the triangle, and the height, remember, must be perpendicular to the base. All right, so this is how I drop down the perpendicular height. Let's just call this h, because at this point I wouldn't know what is h. Now, and we are, since with this 54 area, right, I can now use this area to find the value of h. All right, why? Because I have area, I have base, so remember, half times base times height is equals to your 54. Okay, so later that's what we are going to work on. Now let's look at triangle BCD first. So triangle BCD, notice that I have the 4 cm here. So very obviously, I will treat the 4 cm as the base of this triangle. Now, if 4 cm is the base of the triangle, where is the height? Okay, so likewise, my height is perpendicular to DC, but I have to drop down from corner B here. So drop it down, and this is also the same height as the other one here. So it's also the same H. Okay, so now I have two methods to show you how to do this. All right, so method one is this. Method one is I can use the ratio method. Now, how do I use the ratio method? If you observe for both triangles, triangle ABD and triangle BCD, sorry, they actually share something in common. Okay, and what is the thing that they share in common? So do you all realize that they share the height in common? Right? The same height, all right? So they both have the same height. Now, if these two triangles have the same height, what I can do next is I can create a base ratio. Okay, a base ratio for the two triangles. Why? Because the bases are different for both triangles. Okay, so we create a base ratio. ABD, the base is 12 cm. BCD, the base is this DC 4 cm, right? So 12 is to 4. Simplify, you have 3 is to 1. Now, with this base ratio, what would be helpful next is to create a area ratio. Why? Because anyway, later I need to find area of triangle BCD. Okay, so I create the area ratio because I will know that both areas have to be different for both triangles. Alright, so notice that actually I'm creating ratios for the things that are different for both triangles. The bases are different, that's where I create a ratio. The areas, I know they are going to be different also, that's where I create a ratio. Okay, the height is the only thing that is the same. Now, is it important to create height ratio? You can, okay, but it's not so important because height eventually will just give you 1:1 because it's same height, right? So another reason why we create area ratio is because using the same height, we're going to use this to our advantage. Both triangles have the same height, but the bases are different. Okay, bases are different. So what does that mean? All right, so this means that the area ratio will be in the same proportion as the base ratio. So if the base ratio is 3:1, that means my area ratio, likewise, it will also be 3:1. Now, why does this happen? It's because both triangles, they share the same height. So that means the same height does not matter in the differences between the areas. The area difference is now dependable on the base difference. It's no longer dependable on the height anymore because the height, they both share the same height. Right? Okay. Now, just bear in mind, that being said, also bear in mind that the 3 units and 3 units here have different values, yeah? Because this is the base, this is area unit, this is base unit. So 3 units here could be, 3 units here will be 12 cm, right? It does not mean here that this 3 is 12 also wrong, okay? Because this is area, all right? So two different kinds of ratios. So obviously no common base because they are uh, two different categories of ratio. So once you have created your area ratio, now you can start to link it to this one. Okay, your 54. 54 is the area for ABD. So ABD, we know that 3 units is 54 centimeters squared. And then I will go on to find the area for 1 unit. So I'll just divide by 3, and 1 unit will be 18 centimeters squared. Okay, and you realize that that will be your area of triangle BCD because that is 1 unit. All right, so this is your answer for triangle DBC or BCD. Now I have method 2 to show you. All right, so method 2 is this. Method 2 is not using the ratio, but simply just applying your half times base times height formula. All right, why that works also is because if you look at this triangle ABD, like I said previously, areas are given, base is given. All right, so what's left is just the height. All right, so we're just going to apply the formula. Half times base is 12, times height. Height I do not know, so I just put h. Half times 12 times h. This gives me the area of 54. So you see the only unknown in this equation is your h. So I need to find h. So to find h, simply just use your 54 divided by 12 divided by half. So now that I know the height is 9 cm, this height here will also be 9. And that's where you can start to use your half times 4 times 9 to get your area of triangle BCD.